Now, the concept of equilibrium is a very important one to understand, but very easy at the same time. Now, when an object is in equilibrium, we say it doesn't change. It lacks change, actually. So, because it doesn't change, the velocity is not changing, meaning that there will not be an acceleration. So, by the definition of physics, an object is in equilibrium when it has zero acceleration. So, we can use this to plug into Newton's second law. So, when an object has zero acceleration, then according to Newton's second law, we see that the force has to be equal to 0 too. So, when you're finding for something that is in equilibrium, you know that all the forces added up have to be equal to 0. Therefore, we can use the component of the net force, which is net force in the x has to be 0, net force in the y has to be 0. Let's look at the first concept. In which of the following situations can an object possibly be in equilibrium? Let's look at A. Three forces act on the object. The forces are all along the same line but may have different directions. Now, these forces can all be, for example, force 2 could be 50, force 1 could be 25, and force 3 could be 25 newtons. When these forces push against each other, they completely cancel out, giving a total net force of 0. So A could be a possible chance. Now let's look at B. If there's only two forces, there cannot be they're perpendicular to each other. The resulting force will be another one in a different angle. It will not cancel out. If we look at C and a single force acts on the object, then there will always be a change in velocity. There won't be a force to cancel it out, meaning the net force will not be 0 and the objects will not be in equilibrium. Let's look at number 20. A stone is thrown from the top of a cliff. Air resistance is negligible. As the stone falls, it is in equilibrium or not in equilibrium. Now, as the stone falls, it starts in a velocity of 0 because it's at rest. Now, if it's thrown off a cliff, the velocity will change. So just by the pure fact that we know that the velocity changes, the object will not be in equilibrium. Okay, now during the final stages of a descent, a skydiver with an open parachute approaches the ground with a constant velocity. There's no wind to blow him from side to side. Which one of the following statements is true? Now, if he's at a constant velocity, that means the acceleration is 0. So A, the skydiver is not in equilibrium, could not be a choice. The force of gravity is the only force acting on the skydiver, so that he is in equilibrium. Now, the force of gravity is not the only force acting on him. Normal force is also acting on him, so that cannot be a choice. The skydiver is in equilibrium because no forces are acting on him. However, there are forces acting on him, the downward force of gravity and the upward force of the normal force. So, just by that explanation, you can see that the answer is D.